Namaste everyone, it's me Shailendra. Welcome you to online monastic classes. Today we will discuss about first chapter in C math, that is set. Set is the first chapter in C math for class 6, 7, 8, 9 and 10. Let's start this. When we look the history of set theory, George Cantor was the originator of set theory. That is, who has started the set theory. But all the work was not done by him. It was Leonhard Euler first gave the idea of representing sets by diagram. But he hadn't completed the whole work of this. He was a Swiss mathematician. Later on, British mathematician John Van brought this into practice. So it is known as Euler-Venn diagram. In proper subset, we have learnt about this. If every element of a set A is in the set B and B has no element which is not in A, or simply we can say if A is subset of B and A is equal to B, then A and B are called improper subset. A and B are called improper subsets. Equal sets. Two sets are said to be equal if A is subset of B and B is subset of A. A is subset of B and B is subset of A, or in other words, two sets having exactly the same elements. Like if A and B have same elements, here you can see there are three elements and both are equal, so A and B are equal sets. In another word, you can say A is subset of B and B is also subset of A, then A and B are said to be equal sets. Equivalent sets. Two sets having equal number, like 1, 3, 5. 2, 4, 6. Here three elements, set A has three elements, set B has also three elements, but not the same elements. Number of elements are same. Number of elements are same, but elements are not same. If only the cardinal number is same, then we say A and B are equivalent set. Equivalent set. A and B are equivalent set. Then set of sets or family of sets. When we say sets of sets, go through an example. 1, 2, 3, 1, 2. What are the elements of the set A? 1, 2, 3, 1, 2, and all of them are also a set. So the set, every element of which is itself a set, then it is called a set of set. But if we write 1, 2, 1, 2, 3, 4, anything like that, these two are set, but these two are not. So it's not the set of sets or family of set. So For set of set, the set, every element of which is itself a set, is called a set of set. Power set, the collection of all the subset of a set is known as the power set of the given set. Look through the example. Here set A has only one element. What are the possible subset of the set A? All the possible subsets, all the possible subsets of set A are, that is first two, and we have to remember every set have a subset, that is null set. Here two subsets are, that is 2 and 5. That is, we can say, power set of A. All the possible subset of set A became power set of set A. We represent power set with PA, or we can write 2 to the power A. Both means the same. Power set is represented by 2 ways. PA we will read as power set of A. This also power set of A. When we have to write the subset, if there are two elements like 3 and 5, what will be the power sets? That is all the subset of set B. First will be 3, then 5, then 3, 5, and you know one must be the null set. If there are 3 elements, that is power set of C is first single 1, 2, 3, then 2, 2, 1, 2, 1, 3, 2, 3, then 1, 2, 3, and finally we have null set. So what you have seen there, first number of element was 1 and total number of subset was 2, that is 2 and 5. Total number of subset was 2 here, here is 4, here is 8. We have formula, that is total number of subsets. Total number of subsets is equal to 2 to the power n. That is 2 to the power 3 is equal to 8. But you have to remember every set, that is in every set have two improper set, improper subset. Here in this case, this is also improper, this is also improper. Null set is also the improper subset, and set itself is improper subset. Here the both last one, here also these. So what is the total number of proper subset? Total number of proper subset is 2 to the power n minus 2. Because every set have two improper subset, that is null set and set itself. Now we have universal set. When we say universal set, a universal set is the set of elements from which elements may be chosen to form set for a particular discussion, and it is denoted by the letter U. When we talk about the teachers of monastic school, then all the teachers became the universal set. From this we can make number of sets like group of mathematics teacher, group of science teacher. Same, we can say all the students of monastic school. Then it's the universal set, and if we say students of class 9, students of class 10, these are the subset of universal and these are the sets. Now cardinal number we have learned. If a set A have 3 elements, the cardinal number of the set A is 3. That is the number of elements in a finite set. We can't find the cardinal number of infinite set up to class 10. Later on, different things it will come. Infinite set, we don't have to count. Infinite set, we have the rule that is number of set A, that is what is the total number of elements. One thing you also remember, suppose if you have written 1, 2, 2, 3, here 2 is repeated twice. But you must have to remember these 2 are the same. If you have repeated any number, it doesn't affect, so don't write twice. So A is equal to 1, 2, 3 and cardinal number of the set is 3. Generally we write NA, but there are 3 ways by which we can write the cardinal number of set A. They are these 3. That is HA, modulus of A, but here all represent cardinal number of the set. After the types of set, we have operation on sets. There are 4 major operations on set. First one is union. Look the set A and set B. When we say the union of the set, we have to write all the elements of the set A, set B, or which are the elements of both, either in A, either in B, or both. So we have to write all, that is here 1, 2, 3, 4, 5, 6. Definition wise, the union of 2 sets A and B is a set whose elements are all those which belongs to A or to B or to both. So what you can see here, this is only in A, that's only in B, this also only in A, this only in B, this only in B, but 5 is in both. We have taken all the elements either in A or B or in both. Second one is intersection. For intersection, if we have to take same this, what's the common element in these 2? The common elements in these 2 sets are 5. The A intersection B is 5. The intersection of 2 sets A and B is a set whose elements are all the common elements of A and B. In set builder form, we will define this A intersection B is equal to X such that X belongs to A and X belongs to A. X belongs to B. Here X belongs to A or X belongs to B. When say and, it means both. When say or, it means individually or common, it doesn't affect. Then the third one, difference of 2 sets. A 1, 3, 5, B 2, 4, 6, 5, 6. If we have to find the difference, what's the common elements between these two? Leave the common element. What the elements left in first one? That's the difference between the set A and B. The difference of two set is the difference of two set A and B is a set whose elements are all those that belongs to A but doesn't belongs to B. The 5 belongs to both. That's why you haven't written 5. Only 1, 3 which is in A but not in B. That is the difference of the set A and B. And we have A minus B equal to X, such that X belongs to A but X does not belongs to B. And final operation you have, that is complement of a set. For complement we must have universal. If we take a universal from 1 to 10 and we have the set A, that is 1, 3, 5, 7, and we have to find the complement of A. The complement of A means all the elements which are in universal but not in A. The from universal 1, here is also 1, so 1 will be not taken. 2 is here, here is not, so 2, 3 is in both, don't take 2. Then 3 not, then 4, here 5 cancelled, 6, 7 cancelled, 8, 9, 10. We have to take all those elements of universal which is not in A is called complement of A, and complement of A will be written in 3 ways. We will read all A complement. In set builder method, A complement is equal to X such that X belongs to universal and X does not belongs to A. Now we have the important parts, that's the formula and terminology of sets. These are the things which you have already learned up to class 8. For the student of class 9, you have to know the terminology. That is the words which is used in set by which we will recognize which one is given, which operation is given there. Either it is union, it is intersection, it is difference, it is complement. Terminology will help us. First, for union, the terminology will be used at least one. Either A or B. Either A or B or both. A or B. All these will represent union. At least one. What does at least one mean? When we say at least one of A and B, it means in A and B and both. Remember the point, at least one always represent union. When either is or is in your question, it will always represent union. In terminology wise, union have the words at least one, either A or B, that is either A or B or both, A or B. Then for intersection, we will use as well as, both, and. As well as means as well as, both, and, these all for intersection. Like in your question, it will be there are 10 students who like both of them, who like either of them, A as well as B. This all represent intersection. Complement of union. Complement of union. When we say complement, for question, you have to read it properly. If in question it is talked about past students, then failed student will represent complement of union. But when it is question about the failed student, then its opposite will be pass, then past student will be complement of union. So first thing we have to remember, negative sense it will come. For past it will be fail. Then these are the words which we have already used for intersection, as well as all will give the positive meaning. Don't like A as well as B. Here is also as well as B, but the meaning is negative. Don't like both. Like neither of them. Neither of them. Don't like A and B. All means the complement of union. Complement of intersection. Be careful, these are for when A and B are subsets of universal. We are talking for the only two subsets. Complement of intersection. The complement like at most one of them. What does it mean? Like at most one of them, it means don't like exactly both. Only both. Don't like only A and B. It means complement of intersection. This we will read as and not A, or number of only A. It means in shape language it will given like A but don't like B, or like only A. Same way, and not B or and only B, like B but don't like A, or like only B. Like exactly one. We have used on exactly one and at least one have different meaning. When we say exactly one, that is the sum of the onlys. At least one means that is union. These are the terminology which you used. Then we have to remember few points. Then the formula we will do. When we are solving the question, verbal question, in set, what's the points we have to remember? First point, read the question properly. If there is no negative words in the question, it means universal is equal to union. In that question, universal and union will be same. Or in question, it is said there is no one who don't like both. Don't like both. Then number of universal equal number of A union B, that is number of A union B complement is equal to 0. When there is percentage in the question, then number of universal must be 100%. If we have to solve a question using Venn diagram, and intersection are not given, then suppose it equal x, then using x draw the Venn diagram. That's it.